Right, hi students. In today's video, we're going to understand how the value of the discriminant b squared minus 4ac affects the types of roots of the quadratic equations. Right, so to understand how, before we can actually do a summary of how the discriminant actually affects the roots of the quadratic equation, that's soft sum equation. For example, if you're given this equation x squared plus 6x plus 9 equals to 0, we're going to use quadratic formula to solve it. So let's compare it with your general form of a quadratic equation, which is ax squared plus bx plus c equals to 0. Compare it with this. This is the general form of a quadratic equation. And then you can easily write down the values for a, b, and c. And then let's write down the quadratic formula, and you can sub into your quadratic formula, and you can see that here, this part here, right, it gives you 0, and square root 0 will give you 0. So therefore, we end up getting only one value for x. That means one solution for x. And if you were to look at how the curve looks like, the curve will cut the x-axis at -3. So you can see that there's only one x-intercept. There's only one solution, one x-intercept. Let's do another question. Right, similarly, let's write down, compare it with ax squared plus bx plus c equals to 0. Write down the values for a, b, and c, subbed into your quadratic formula, and you can see that this part here, again, is a 0, so square root 0 will give you 0. So you end up getting one value of x, only one solution of x. And if you sketch the curve, you can see that the curve cuts the x-axis at x equals to -12, and there's only one x-intercept. All right, so from here, okay, observe that in both examples, the value for b squared minus 4ac is 0. So when the values for b squared minus 4ac is equals to 0, right, you only get one solution, one x-intercept. All right, so let me repeat. If the value of b squared minus 4ac is equals to 0, okay, we will only have one solution or one x-intercept. Okay, or one root. They are equivalent. One solution, one x-intercept, or one root, they're equivalent. So hence, to describe this kind of root, we say that the equation has two real and repeated, or two real and equal roots. So the question you ask me is, your questions that you may ask me is, on the screen, I only see one solution of x. Let's say, for example, if you look at x squared plus 6x plus 9 equals to 0, you get x equals to -3, right? If you look at 4x squared plus 4x plus 1 equals to 0, you only get x equals to -12. Then why do you say it's too real? Why is it there's a 2 there? Okay, I'm going to use factorization to solve the quadratic equation. Okay, the three methods, if you were to recall, there are three ways of solving the quadratic equation. You can solve it using quadratic formula, using factorization, or using completing the square. So if you use factorization, you will see that we would have two linear factors, 2x plus 1 equals to 0, or 2x plus 1 equals to 0, and x equals to -12. The other one is x equals to -12. So logically speaking, a quadratic equation will have two roots. In this case here, these two roots happen to be the same. All right, it happen to be the same. That's why we describe it as two real and repeated, or two real and equal roots. All right, so in general, what I did just now was to give you some quadratic equation. So if I'm going to replace it, use what do you call that? A general form, right? Use a quadratic formula to explain, right? if your b squared minus 4ac is equals to 0, right, you will see that you only end up getting one solution. Okay, in the first example, you get x equals to -3. The second example is x equals to -half. All right, so these types of roots of the equation, okay, let's summarize again. If the value of your b squared minus 4ac is 0, then this type of roots of the equation is called two real and repeated or two real and equal roots. Okay, let's move on. Right, let's go on to solve some more questions. All right, some more equations, sorry. So if I have x squared minus 5x plus 4 equals to 0, all right, right now the values of a, b, and c, substitute in your quadratic formula, and you see that you actually managed to get two answers for x. One is 4 or 1 is 4, the other one is 1. And if you were to sketch the curve, you will see that the curve actually cuts the x-axis at x equals to 1 and x equals to 4. So there are two x-intercepts. Right. And if you look at the one that I've highlighted for you, what did you observe? Yes, you observe that the value of b squared minus 4ac is actually a positive value. 9 is a positive value. Right, so let's look at another equation. Okay. Right, so you will end up also getting two solutions. X equals to 1 or x equals to -half. If you sketch it, you have two x-intercepts. All right, so what is the conclusion we can make here? So the conclusions we can make here is if the value of your b squared minus 4ac is more than 0, that means if it's a positive value, okay, you will end up having two x-intercepts. You end up having two x-intercepts. Oh, sorry, there's no only there. Just cancel off the only. You will end up having two x-intercepts. Okay, and to describe this kind of roots of the equation, you describe it as two real and distinct. Distinct means unequal, not the same. Okay, so this kind of roots is described as two real and distinct or two real and unequal roots if the values of your b squared minus 4ac is more than 0. All right, let's solve some more equations. Okay, let's look at this one here. You're given -2x squared minus 5x minus 4 equals to 0. If you compare it again with the general form, which is ax squared plus bx plus c equals to 0, write down the values for a, b, and c, substitute into your quadratic formula. Right, and let's see what happened. Yes, and you actually get a negative value for your b squared minus 4ac. And if you're going to use a calculator to evaluate square root -7, the calculator will give you some, will give you answer as undefined, give you an undefined answer, meaning that is no real values for square root negative. Okay, you can solve it. It's a complex number, but at your syllabus, at your level, we take it as there's no real values if you have a square root of a negative number. If you were to sketch the curve, all right, your values of a is -2, which is less than 0. You get an N-shaped curve, which is not exactly, sorry, which is entirely below the x-axis. It does not cut the x-axis at all. So it has 0 x-intercept. So let's look at another example. 3x squared minus 7x plus 9 equals to 0. Okay, write down the values of a, b, and c, substitute into the quadratic formula. I want you to look carefully at the value of b squared minus 4ac. You're getting a negative value, right? And if you use a calculator to evaluate square root -59, you will not get an answer because there's no real values, right? So if you sketch the curve, this is a U-shaped curve because the values of a is positive. So you get a U-shaped curve and the curve is entirely above the x-axis. It does not cut the x-axis at all. Therefore, it has 0 x-intercept. Right, so what is the conclusions we can make here? Right, so the conclusions you can make here is if the values of a b squared minus 4ac is less than 0, we will end up having 0 x-intercept. Okay, please cancel this only. We will end up having 0 x-intercept. Okay, the curve is either entirely above the x-axis if its value of a is more than 0. If the values of a is less than 0, it's entirely below the x-axis. And there's no real values of x, no solutions. Okay, so in this case here, we describe it as the roots of the equation is called no real roots. There's no real roots for this kind of equation. If the values of b squared minus 4ac it's a negative value. Okay, right, and there's actually a fourth case where we need to combine the values of b squared minus 4ac equals to 0 and b squared minus 4ac more than 0. You combine them, you get b squared minus 4ac more than or equal than 0. And this kind of roots, they are just called real roots, right? So in summary, all right, if you have 0 x-intercept, you have no real roots. That is when your value of b squared minus 4ac is less than 0. If it's more than 0, means you have 2 x-intercept, and it's called 2 real and distinct roots. If you have equal to 0, right, you have 1 x-intercept, and they are called 2 real and repeated roots. And if you have the values of b squared minus 4ac more than or equal than 0, then the roots is just called real roots. Right, so in summary, okay, this is very important. This summarizes what we have learned for the first few slides. Okay, summarizes what we have learned, right? Values of b squared minus 4ac less than 0, the equation has no real root. The value of b squared minus 4 equal to 0, the equation has 2 real repeated roots. If the value is more than 0, the equation has 2 real distinct roots. And if it's more than or equal to 0, then the equation has real roots. So these 4 cases, you have to remember it. Alright, so we're going to put our knowledge into practice. So this is the moment of truth to see if we can apply what we have just learned. Let's look at this question. You're given a curve, which is y equals to negative 2x squared plus x plus k. And this curve, you are told that there's no x-intercept. No x-intercept. Right. So when you have no x-intercept, and if you were to compare this curve with the general quadratic form, right, we can see that a is equals to negative 2, which is less than 0. So you have an N-shaped curve. And if you have no x-intercept, means your curve is entirely below the x-axis. There's no x-intercept, no solution. So this guy here means no real roots. So no real roots means what is the value of your b squared minus 4ac? Yes, it's less than 0 if you were to recall. So we plug in the values for a, b, and c, and we end up getting a inequality, right, where k is less than negative 1 over 8. Alright, back to the same questions, but now we're going to do part 2 when you're told that the curve has one x-intercept. So what does one x-intercept remind you of? It's an N-shaped curve, so it cuts the x-axis at only one point. Right. So since the curve has only one x-intercept, then can you recall that the values of b squared minus 4ac will be equals to 0. So this is what we're going to do. And then you end up getting the values of k equals to negative 1 over 8. Alright, let's try to do another question. So the questions could be such that instead of telling you that it has 0 x-intercept, 1 x-intercept, the question can be such that you are told that this curve has 2 real and distinct roots. Right, so 2 real and distinct roots, Are you able to recall how is it related to the values of b squared minus 4ac? Yes, so if the curve has two real and distinct roots, means the values of b squared minus 4ac is a positive value, right? So we do the same thing. Right now, the values of a, b, and c sub into your b squared minus 4ac, let it be more than 0, and you end up getting a inequality where your k is greater than negative 1 over 16. All right, so we have just done some very simple applications, right? But if you understand the concepts well, you'll be able to solve many more questions. So the important thing is to get the concepts correct, right? So let's do a summary again. Real roots means the values of b squared minus 4ac is more than equal than 0. No real roots means the values of b squared minus 4ac is less than 0. Two real and distinct roots means the value of b squared minus 4ac is more than 0. Two real and repeated roots means the value of b squared minus 4ac is equal to 0. Okay, so that ends the video here.